In this work, we present a novel way of producing realistic and reactive gaze behaviors for virtual characters. This method relies solely on the field of view of the character and does not require any scripting or labeling of the objects of the scene. The first step towards generating a new eye fixation from the character is to render its field of view. The rendered image is then passed through a visual saliency model, which outputs an eye fixation probability for each pixel. Then, this saliency map is combined with several human oculomotor biases and merged into a distribution from which we draw the next fixation point. At the same stage, a duration for the fixation is also sampled. Finally, given the current eyes and head orientations of the character, the model will animate the character's gaze towards this new fixation point. When the duration of the fixation is reached, the updated field of view of the character is rendered, and the process is then iterated. For each new fixation, several feature maps are computed based on the rendered field of view of the character. A visual saliency map, representing what in the scene is important and likely to be observed. A saccadic orientation and amplitude map, representing human oculomotor biases. A map modeling the inhibition of return in order to avoid getting stuck in the local maximum and to favor visual exploration of the scene. And depending on the context, several customization maps can be included. In this case, since the character is exploring the scene, we add a horizontal bias map to model the tendency of eye fixations to be located along the horizon. These maps are then combined together, and the next fixation point is sampled. In cases where we might want a character to look at a specific object or area, for instance, in order to react to a specific event, we can use an optional attention map which defines a mask around manually specified areas of interest. In this example, we want the character to look at the football game on the television. Although the TV set is not particularly salient in the scene, it is semantically very important. We then include the TV-centered attention map in the combination and proceed to sample the next fixations. Here are a few examples of the outputs of our model. We performed an objective evaluation, comparing the simulated gaze tracks with those of real humans placed in the same virtual scene. We show that the generated eye fixations share significant similarities with human fixations, both in their locations and dynamics. We also performed a subjective evaluation in order to assess the perceived realism of the simulated gaze behaviors and the perceived awareness of the character. We show that the gaze behaviors generated by our model cannot be distinguished from captured gaze animations.